This paper, oh man, it just like blew my mind. It totally changes how I think about where AI is headed. And I think you're going to love this too. So you want to know how to make AI even smarter, like really smarter, especially those large language models, the LLMs, the ones that can almost write like a person, right? Well, this research, it goes deep into making those LLMs better at reasoning, like actually thinking things through. And get this, they did it without using those huge secret data sets that the big tech companies are always hoarding.
What's so amazing here is that they did this all in the open source world. It's a total game changer because it means smaller teams, with fewer resources, can still make AI that's just as powerful as what those tech giants are building.
It levels the playing field. This paper, it's all about ScaleQuest. And that's their method for creating a ton of top-notch data to train these open source LLMs. And get this, they used math problems as their testing ground, which is actually brilliant when you think about it. It's a perfect way to see if an AI can think logically, like step by step, right?
Yeah, exactly. Math gives you that clear measurement of how well an AI can reason. And the results they got with ScaleQuest, well, they're amazing.
Get ready for this. They actually managed to match and sometimes even beat the performance of commercial models like GPT-4. And they did all of this using smaller models, the publicly available ones. It's crazy. A small team using public data built an AI that's beating the giants at their own game. So how did they do it?
Well, it all starts with solving a big problem in AI. The data problem. LLMs, especially the ones trying to do complex reasoning, they need a ton of data. Massive amounts to learn properly.
And we all know the best data, it's usually locked away by those big tech companies, which puts developers working in the open source world at a huge disadvantage.
Exactly. And that's where ScaleQuest comes in. It's this really clever two-step process that's designed to train open source LLMs to generate their own math problems. And I mean completely from scratch.
Whoa, hold on. Are you saying they're teaching the AI to become like its own math teacher?
Yeah, basically. It's a really cool approach. The first step is what they call priming the pump. So they train the model on just a small set of existing math problems just to get things started, just to give the AI like a feel for what these problems look like.
But they don't want to overload it at this stage, right?
Right. You don't want the AI just memorizing those existing problems. That wouldn't be real learning, would it? So they actually train it for just one epoch, which is like one pass through all the data.
Oh, okay. So that's the initial training. But if it's going to become a pro at making its own problems, it needs more, right? This is where it gets really interesting.
Yeah, for sure. They bring in another AI, kind of like a problem critic, and its job is to like refine the questions the first AI comes up with.
So it's like a quality control expert,
Yeah.
making sure the questions make sense, are solvable, and are challenging enough.
Yeah, you got it. The critic AI makes sure those generated questions are like logically sound and that they have the right difficulty level too. That's super important for making sure the data is really high quality. And using this two-pronged approach, they were able to make a data set of 1 million math problems and their solutions.
That's incredible. But how did those open source LLMs actually do when they were trained on this ScaleQuest data?
Right.
Like, how did they stack up against the models trained on all that proprietary data?
Well, that's where things get really exciting. The results. Let me tell you, they were really impressive. These smaller open source models trained on public data often did better than the much larger models trained on those private restricted data sets. It really makes you think, doesn't it? Bigger isn't always better in the AI world.
I love it. A real underdog story. Can you give us some specific examples? Like, which models went head to head and who came out on top?
So they took this model, it's called Qwen2 Math 7B, and they fine-tuned it with the ScaleQuest data. And get this, the smaller open source model, it actually beat out the performance of giants like GPT-4 Turbo and Claude 3.5. On certain benchmark tests, I mean...
Wow, that's a serious David versus Goliath victory. But it's not just about performance, is it? This approach is also way cheaper than relying on those expensive APIs from the big tech companies, right?
You're absolutely right. This really democratizes AI research and development. The fact that they generated this massive data set in just 2.7 days on a standard server.
Wait, hold up. They did all of that with just 8 GPUs. That's unbelievable.
Yeah.
That's the kind of setup that smaller research teams or even independent developers could actually get their hands on.
Exactly. It opens up the field so much more. You don't need the resources of a Google or an OpenAI to make real progress now. And there's another really interesting point here. The paper shows that the quality of the questions you use to train an LLM actually matters more than just having a ton of data.
So it's not just about like force feeding the AI a million random math problems. It's about being picky, right?
Yeah, exactly. It's quality quality over quantity. ScaleQuest focuses on making diverse, challenging, and logically sound problems. It's like a carefully curated menu of brain teasers, ones that really push the AI's ability to think.
And they found that using multiple AI models to generate different types of questions gave even better results.
Right. Yes. Think of it like a team of AIs, all brainstorming the best possible questions. Each AI model brings something different to the table, which leads to a richer and more varied data set. It's like having a panel of expert math teachers, each with their own style, coming together to create the ultimate training program.
Okay, let's zoom in a little on how they actually train these problem designer AIs, the ones creating the math questions. We know they start with those smaller open source LLMs, but how do they guide them to become like expert question generators?
It's a multi-stage process, and each stage, refines the AI's abilities. It's all about making sure they end up making really high-quality questions. The first stage is called question fine-tuning. They call it QFT for short.
So it's like they're giving the AI Math 101, right? Just a basic understanding of what a good math problem looks like.
Yeah, that's a great way to put it. They train it on a small, mixed set of problems from existing data sets, like GSM-8K and math. This gives the AI a feel for the structure and the style of typical math questions. But they only train it for one epoch to prevent overfitting, just to give it the basics.
One epoch. What's that?
It's like one complete pass through the entire training data set. Imagine studying a textbook just once to get the main ideas without getting bogged down in all the details. This way, the AI learns the general principles of math problems without just memorizing specific examples.
Got it. So it gets a solid foundation, but it's not ready to write its own textbook just yet. What happens next?
The second stage, this is where it gets really interesting. It's called Question Preference Optimization, or QPO. Here, they use a really clever trick. They train the AI to actually recognize what makes a good math problem. It's like they're giving it a taste for, really challenging questions.
So they're teaching the AI to be its own critic. That's fascinating.
Exactly. They use another AI, a really skilled one, kind of like a math teacher AI, to evaluate the questions made by the first AI. And this expert AI, it looks for two main things: solvability and difficulty. They want to make sure the questions are logically sound and challenging, but not impossible to solve.
It's like a feedback loop, right? The first AI makes questions, the expert AI critiques them, and then the first AI learns and improves from that feedback.
Exactly, like a student working with a tutor. This back and forth really helps the AI understand what makes a great math problem. But even with all this training, the AI might still come up with some duds, so that's where the final step comes in: filtering.
Filtering. What do they do in that stage?
They use a few different techniques to get rid of poorly worded or unsolvable questions. They've got another AI acting as a fact checker, making sure the questions can be solved logically with the information given. And they also use some statistical analysis to find questions that are too easy or too hard. It's all about making sure there's a good balance of challenge levels in the final data set.
Wow, it sounds like they have a whole team of AIs working together. A question generator, a critic, a fact checker. Like an assembly line for making perfect math problems.
Aha, yeah. It's a great way to picture it. Each AI has a really important job, making sure the final data set is high quality and diverse.
This is incredible. We've talked about the theory, the training process, but let's get to the results. How did those open source LLMs actually perform against those industry giants?
They tested these LLMs on 4 different benchmarks. Each one's designed to measure performance at different difficulty levels.
So it's like a gauntlet of math challenges.
Yeah. They started with GSM-8K, the one focused on elementary and middle school problems. And then they moved on to math, which is for high school competition level problems.
Oh, wow.
But they didn't stop there.
Okay, I'm on the edge of my seat. What else did they throw at these LLMs?
They wanted to see how these models would do with some really tough problems. So they also included college math. That one, as you might guess, focuses on college level math problems.
Makes sense.
And then, get this. They also used the Olympiad bench.
Olympiad bench.
Yeah, those are the super hard problems they use in math Olympiads. You know, those competitions for the best young mathematicians from all over the world.
Oh, wow. They were really trying to push those open source models to their limits.
They wanted to see if these smaller models could really compete with the best of the best.
And what happened?
The results were better than anyone expected. Across all 4 benchmarks, the open source LLMs, the ones trained on that ScaleQuest data, showed massive improvement.
Okay, give me the numbers. How much better did they actually perform?
So let's take the math benchmark, for example. Remember that smaller model we talked about, Qwen2 Math 7B?
Yeah, the one that beats some of the bigger models.
Well, after training on the ScaleQuest data, it got an accuracy of 73.4% on those math problems.
Hold on. 73.4% on those tough high school competition problems. That's incredible, especially for a model of that size.
It is. And it's even more impressive when you realize that's basically the same performance as GPT-4 Turbo.
Wow. That's one of the leading industry models.
Right.
So this smaller open source model trained on public data is performing just as well.
Exactly.
That's a huge win for the open source AI community. It really shows what's possible when you've got smart techniques and high quality data.
And there's more. The researchers found that the more ScaleQuest data they used, the better the LLMs performed.
So this approach really is scalable. It's not just a one-time thing.
Right. It's not just a fluke. It's got real potential.
Yeah.
Think about it. What if they created data sets with like tens of millions of problems or even hundreds of millions?
That's mind-blowing. And we can't forget, they made that million problem data set in just a couple of days using regular hardware.
Yeah, that's what makes this so exciting.
It's a real testament to how accessible and affordable this approach is.
Exactly. It means that cutting-edge AI research is something that more people and organizations can actually do.
Okay, so we've talked about a lot today. The data problem, the ScaleQuest solution, those amazing results, and how democratic this research is. But this is just one study, right? And it's focused on math.
You're right, and that's an important point. Math is a great way to test reasoning abilities, but it's only one part of AI.
So the big question is, can this ScaleQuest approach work in other areas too?
That's the question everyone's asking.
Like, can we use it to make super smart AIs that are great at science or law or even art?
The researchers think so. They're already looking at how to adapt these techniques for other fields.
Wow. It's like giving AIs the tools to become true partners in discovery and creation, you know?
That's what makes this so exciting. It's not just about making AI smarter. It's about finding new ways for AI to work with us, to help us push the boundaries of what humans can do.
So what does all of this mean for you, the listener? This research is a wake-up call. It shows that we can shape the future of AI. We can guide it towards things that benefit all of us. And the best part is you don't need to be a big company with tons of resources to make a difference. Go explore the world of open source AI, learn about these new techniques, and see what amazing things you can create. This research has opened a door to a future full of possibilities. What will you discover on the other side?